The Greek world gave birth to scientific thought by means of observation, investigation, and elaboration of theories, based on experience. Greek thought further developed and set a standard for the fields of science, mathematics, and philosophy in the Western space. As per Greek civilization, thoughts and ideas arising in this space should be treated as a whole, and not just particular products of individual people. Homer and Hesiod were the educators of Greece and a traditional source of information about the gods. In the archaic phase of their civilization, Greeks transmitted the memorable orally, in the form of poetry, which often relied on myth. What we call nowadays myth is something to be debunked. A widespread popular belief that is false. They in fact called these mythos, which were quite different from myth. For them, a mythos was a true story, a story that unveils the true origin of the world and human beginnings. However, later, two types of discourse emerged that were set in opposition to poetry: history and philosophy. These types of discourse were naturalistic alternatives to the poetic accounts of things. Plato uses both traditional myths and myths invented by himself and incorporated these in his philosophical endeavor. He overcomes the traditional opposition between mythos and logos. Plato, with his idealism and the development of his theory of forms, became so recognized in his time, and later, in European space, that he is widely regarded the apogee of Greek thought, alongside his student, Aristotle. Although these two have contributed significantly, Homer and Hesiod are the original authority dominating Greek thought. Mythology is not scientific, but we find cosmological elements in it, although the elements and processes are disguised under the veil of epic stories. The Greek mythology is closest in time to the Egyptian, Phoenician, and Sumerian accounts of cosmogony. It is infused with Thracian, Slavic, and Norse elements. It is based on the oldest accounts of Proto-Indo-European beliefs. We will return to these accounts after we establish an appropriate vocabulary for deciphering these ideas, in a more scientific key. For now, I am interested in explaining the four elements of nature, based on the pre-Socratic exposure and contemporary scientific thinking. The pre-Socratics were interested in cosmology, the beginnings, substance, and change of the universe, the causes and principles of the natural world, the arche. Their explanations were based on natural laws, rather than the actions of gods. Their particular knowledge, due to the fact that it is not connected, does not constitute understanding. Although the maxim inscribed in the forecourt of the Temple of Apollo at Delphi reads "Know thyself," knowledge is not understanding. The Milesian philosophers, Thales, Anaximander, and Anaximenes, proposed that everything in the world is made of the same thing, a single, permanent substance, and not an infinite plurality of things in flux. The Milesians generated ideas about actual things. Later, the idealists generated abstract models of perfect things. Just as the world is a cosmos, an ordered arrangement, so too, the human knowledge is ordered in a corresponding way. The cosmos is to be considered a large form, whereas an object is to be considered a contained form. Astronomer, mathematician, the first philosopher and the first of the seven sages, Thales of Miletus, is at the origin of scientific thought. He introduced geometry into Greece, from Egypt, and he supposedly predicted a solar eclipse in 585 BC. Along with Anaximander and Anaximenes from Miletus, they set the basis of philosophical thought in the Western space. The Milesian thinkers are distinguished by Aristotle as inquirers into nature, as opposed to the myth-makers Homer and Hesiod. They explain things only in terms of their matter. In Aristotle's view, an explanation must include four factors: material, efficient, formal, and final causes. Thales claims that the principle of all things is water. This idea is to be regarded as an abstract concept, not in a concrete, personified way, as we find in mythology. There is a concrete mythological creation from waters, in the Sumerian space. And there is a philosophical counterpart in China, found in the way of Taoism. Anyway, we are in the Greek space, so Aristotle adds to Thales's claim that the world rests on water. That from which things come to be is a principle of all things. He suggests Thales chose water because its fundamental role in coming to be, nutrition and growth, and claims water is the origin of nature. The pre-Socratics claimed a single enduring material that is both the origin of all things and their continuing, uninterrupted nature. So, on this view, when Thales says the first principle is water, it should be understood as, that both the original state of things was water, and even now, despite appearances, everything is really water in some state. The change from the original state to the present one involves changes in the material in such way that it may not appear to be water everywhere, but it seems to be airier or earthier than water in its original state. In chemistry, there is something called the triple point of water, the point in which water finds itself in three states: solid, liquid, and gas, all at once. In Thales's view, there is no transformation of water into a different state of matter, into air or earth for example. Everything is water in some form. For Thales, water was fundamental because everything comes from it. It is a necessary condition for everything to emerge naturally and be sustained by it. Water sustains life. We first start with the basics of what water is and then advance towards a more essential exposition of how water behaves. We will carry these elementary notions in all further videos and gradually build complexity upon them. In chemistry, the basic understanding is that water is a polar molecule, a group of atoms bonded together, the molecule being the fundamental unit of a chemical compound that can take part in a chemical reaction. In this case, we have two atoms of hydrogen bonded to one atom of oxygen. Hydrogen is colorless, odorless, tasteless, and highly combustible. It first formed during the recombination epoch, 379,000 years after the Big Bang, along with helium, these being the first atoms in the universe. Hydrogen is one of the lightest elements in the periodic table and the most abundant substance in the universe. Its interaction with helium led to the formation of the first stars. Hydrogen is a discrete substance and its name comes from Greek, meaning water former. The study of its energetics and chemical bonding played a key role in the development of quantum mechanics, because hydrogen is the only neutral atom for which the Schrödinger equation can be solved analytically. Oxygen appears much later in the universe as it is created by stars after they finish burning hydrogen. Oxygen is the third most abundant element in the universe, after hydrogen and helium, and on Earth it occurs mainly as an element in the atmosphere. It is continuously replenished in Earth's atmosphere by the process of photosynthesis. It can form ozone, which acts as a shield and absorbs most of the sun's ultraviolet radiation. The hydrogen atoms each share an electron with the oxygen, in what we call a covalent bond. The electron is an elementary particle with a charge of negative electricity, found in all atoms and acting as the primary carrier of electricity. The proton is a positively charged particle, equal in magnitude to the electron. In addition, we further find neutrons, which have the same mass as the proton, but are not electrically charged. The neutron is present in all atomic nuclei, except that of hydrogen. The positive pole around the hydrogen atoms bonds to the negative pole around the oxygen atoms of a different water molecule. This results in a high cohesion for water, which results in high surface tension, a property of the surface of a liquid that allows it to resist an external force, due to the cohesive nature of molecules. Cohesion is the attraction between two like things, like the attraction between one water molecule to another. Water molecules are holding the droplets together in a configuration that creates the least amount of surface area. Adhesion is the attraction between two different substances, like the attraction between water molecules and, let's say, glass molecules. Water can defy gravity through capillary action. The surface tension created in a tube, through adhesion and cohesion, causes water to rise through the cylinder. At 0 degrees Celsius, water molecules start to solidify and the hydrogen bonds form crystalline or lattice structures that space molecules apart evenly, thus making frozen water with a lesser density than liquid water. Ice is capable to float on water. If ice was denser than water, it would sink. This is important in aquatic ecosystems, the medium in which life forms and emerges from. Water also has a very high heat capacity, meaning it is hard to significantly heat up and cool down oceans. Thus, oceans regulate the temperature and the climate of our planet. Heat excites the water molecules to the point that they break the hydrogen bonds and evaporate. If we are descriptive, we can say that with the expansive water surface around an object, a second image is created. This mirror image has different attributes and it is inseparable from the first one. One object reflects one. Water has an immediate and instinctive beauty, it has a universal value for expression, it is a material which transmits vibrations, it doubles images, and expresses complexity. Every particle reflects and reveals the qualities and attributes of its system. The part reflects the whole. The concept of water is a vast subject and its importance is recognized across civilizations and cultures. In our presentation, the concept of flow is central to this element. First of all, water is the basis of fluids of living organisms, being a substance that can flow and has little resistance. It has no fixed shape or form, being able to take the form of any recipient or container. We could fill a cup with all existence. In physics, flowing means deformation under an applied external force. We all know the famous example of ripples in a pond and that water can generate surface waves, or ripples in the spacetime continuum. In physics, a wave is a change from a state of equilibrium. It is a propagating dynamic disturbance. Waves can oscillate or vibrate at some frequency or amplitude, and we know that light manifests itself as both particle and wave. I think I will do another video on this, but now let's concentrate on this man's observations and intuitions. Thales may have thought that certain characteristics of the original water persisted. In particular, its capacity for motion, which must have been innate in order to generate the changes from the original state. It is suggested that Thales claimed that the lodestone, with its magnetic properties, and amber, which when rubbed exhibits powers of electricity, have souls, and that all things are full of gods. Aristotle supposed that Thales identified soul, that which makes a thing alive and thus capable of motion, with something in the whole universe, and so supposed everything was full of gods. For him, water, or soul, being a divine natural principle. So, for Thales everything lives and moves due to the water element. I am particularly trying to explain this man's observations and intuitions from a scientific point of view. There are terms which have no scientific equivalent, but we can explain some of the concept of water and its behavior in scientific terms. So, regarding the lodestone and amber, we find in physics that an electric charge can be positive or negative. It is the property of matter to experience a force when placed in an electromagnetic field. Charge can be quantized and is measured in coulombs. The Coulomb or electrostatic force is responsible for the interaction between the electron and the proton in the hydrogen atom. Like charges repel each other and unlike charges attract each other. An electric current is a moving electric charge. It is a stream of charged particles that flows through space. The unit of measure is the ampere, and it is measured as the rate of flow of electric charge through a surface or into a volume. Electric charges generate electric fields, and electric currents generate magnetic fields. They can also generate heat, which produces light. A magnetic field is a vector field that describes the magnetic influence on electric currents. Electromagnetic fields are composed of electric fields and magnetic fields, and are responsible for electromagnetic radiation, such as light. When these fields oscillate or vibrate, they generate electromagnetic waves. Electrons only emit photons when moving from higher orbit to lower orbit, or from a higher energy state to a lower energy state. Electromagnetism is one of the four fundamental forces of nature. Electromagnetic waves are closely compared and similar to gravitational waves, which are considered ripples in spacetime, and which propagate outward from their source at the speed of light. In similar fashion, just as moving electric charges generate electromagnetic radiation, so too, the gravitational charges, meaning mass, generate gravitational radiation, a form of radiant energy. The electromagnetic fields are best described by Maxwell's equations. Maxwell was able to unify the entirety of electromagnetism into four equations. First equation says that an electric charge of any shape produces an electric field. Second equation says that magnetic field lines have no beginning and no end, unlike electric field lines. Magnetic field lines are continuous. Third equation says that a changing magnetic field will induce an electric field. Fourth equation says that a magnetic field is produced by a current or by a changing electric field. They establish the speed of light based on two properties of the medium of propagation: permeability and permittivity of space. They measure the resistance of space to changing electrical and magnetic fields. This led to the development of Einstein's special theory of relativity in 1905. It is important to mention that actual water is a diamagnetic material, which is repelled by a magnetic field. The magnetic permeability of diamagnetic materials is less than the permeability of vacuum. Electromagnetic radiation consists of waves of the electromagnetic field, which carry electromagnetic radiant energy. All of these waves form part of the electromagnetic spectrum. They are synchronized oscillations of electric and magnetic fields. The frequencies range from below 1 Hz to above 10 to the power of 25 Hz. The lowest frequency implies long wavelength, and these are radio waves. The highest frequency implies short wavelength, and these are gamma rays. Ultraviolet, X-rays and gamma rays are classified as ionizing radiation, because their photons have enough energy to ionize atoms, causing chemical reactions. They have the ability to alter the DNA. Electromagnetic waves are free to radiate or propagate themselves at the speed of light, without the continuing influence of the moving charges that generated them. In quantum mechanics, the electromagnetic radiation consists of photons, uncharged elementary particles with zero rest mass. They are the quanta of the electromagnetic field. The energy of a photon is quantized and is greater for photons with higher frequency. This relationship is given by Planck's equation. I could raise now the following question. Have you wondered why the sky is blue? The color of the sky and the color of the ocean are related, but they occur independently of each other. In both cases, the preferential absorption of red light gives rise to the blue. Violet and blue light have the shortest wavelengths and red light has the longest wavelength. As white light passes through our atmosphere, air molecules cause it to scatter or disperse. When energy waves are caused to depart from a straight path due to imperfections in the medium, it is called scattering. The scattering increases as the wavelength of light decreases. Electromagnetic wave scattering corresponds to the collision of a wave with some material object and its implicit scattering. Another example is sunlight scattered by raindrops to form a rainbow. Relativistic scattering experiments are a context in which quantum mechanics is said to fail. Since the involved particles often travel close to the speed of light, relativistic effects cannot be neglected, but this process can be further explained by quantum field theory. So, this is why the sky is blue. We now advance our presentation, in order to bring to the surface how things flow in our understanding of nature. The concepts of water and flow will be paramount and strictly related to anything that will follow in these exposures. In physics, flow is described by fluid dynamics and it is a property of liquids and gases, which are both fluids. We find that things can flow or be in flux, radiate, emit, emanate, flood, outflow, pour out, cascade, etc. These are different words for the same concept. Even in music, we find flow as an expressed property of voice. Let's now expand more on the scientific notion of flow. Thus, we arrive at an intuition, and that is called divergence. In physics and mathematics, it is the compression and expansion of a vector field, or a decrease and increase in its density. Examples of vector fields can be the magnetic field and the gravitational field. A vector is a quantity having direction and magnitude, and determines the position of one point in space, relative to another. The divergence of a field is the change of volume of a flow. It is the extent to which the field flow behaves like a source at a given point on the plane. In order for it to flow, the vector field must have velocity, so it has to be a fluid in motion. Divergence is a local measure of its extent, to which there is more quantity exiting an infinitesimal region of space than entering it. So, first, a field can flow relative to a source point and it can have zero divergence, positive divergence or negative divergence. A source of positive divergence outflows and it needs to have a source of that fluid, in order to keep things sustaining. Negative divergence is actually a convergence, an inward flow, where the source acts like a sink, collecting fluid. A source with zero divergence means the amount flowing in and the amount flowing out is balanced, and there is no change in density. Maxwell's equations are expressed as the divergence and curl of electric and magnetic fields. The curl of electric and magnetic fields is responsible for giving rise to electromagnetic radiation, meaning light waves. Curl is the rotation of a flow around a point. A positive curl is in a clockwise direction and a negative curl is in a counterclockwise direction. A zero curl means the vector field is irrotational. There is a property called superfluidity. characteristic to fluids with zero viscosity, which therefore flow without any loss of kinetic energy. When stirred, a superfluid forms vortices that continue to rotate indefinitely. There are also materials which, when cooled enough, can conduct electricity without energy loss, where electrical resistance vanishes and magnetic flux fields are expelled from the material. This property is called superconductivity. Electrical resistance counteracts the flow of current and is measured in ohms. Magnetic flux measures the total magnetic field that passes through a surface area and is measured in Webers. Back to actual water and further, a drop of water, which we will call here a cluster, contains many molecules, which are linked together by hydrogen bonds or bridges. The hydrogen bridges can be altered with specific intensities and wavelengths, by sonic molecular structuring. Basically, if you emit a sound, water will take the shape based on that sound and frequency. Our body operates based on frequencies and oscillations, and its composition is made on average of 60% water, with the brain and the heart being composed of 75% of water. Frequency has an intense effect in our bodies and minds. The vibration starts at a source point and propagates at equal speed in circular waves towards the edges. If the edges are not at equal distance from the center, they are reflected back at different times. At certain points, the local sum of all the amplitudes of the waves going back and forth is zero, and that is where the points will relocate to. The shape of the pattern is decided by the frequency of oscillation, the rigidity, thickness, and shape of the support, base or substratum. This is greatly dependent on the lattice structure of the substratum. The higher the frequency, the more nodes and antinodes form according to the phononic interaction within a crystalline structure. A phonon is a definite discrete quantum of vibrational mechanical energy or sound waves, just as the photon is a quantum of electromagnetic energy or light waves. In fluid dynamics, frequency dispersion is the dispersion of water waves propagating on the water surface, with gravity and surface tension restoring them to equilibrium. Water is a dispersive medium, and we can say that it has a free surface, an interface surface between two mediums, water and air. Furthermore, a Fermi surface is the surface which separates occupied from unoccupied electron states at a temperature of 0 Kelvin. The Fermi surface is a consequence of the Pauli exclusion principle, which allows a maximum of 1 electron per quantum state. Unlike the visible world around us, the world of atoms is in a constant state of motion at all temperatures above absolute zero. We will cover temperature in depth in the next video, which will be about an aximander. The following process is done on normal and superconducting metals as the substratum, by measuring the tunneling current through a junction barrier between the two metals. In the quantum world, electrons and quasiparticles have wave-like properties, and if they don't have enough energy to move over a barrier, they go through, by the process of quantum tunneling. The electron-phonon interaction is a major scattering mechanism. It scatters electrons based on the thermal motion of the lattice. It is the source of attraction that binds two electrons into a paired state. Unlike electrons, these paired states are allowed to be in the same quantum state. These interactions greatly depend on temperature, which measures how widely the atoms move in a system. Thermal generation is the process of electron state promotion through phonon interaction. The process through which electrons relax into lower energy states, returning energy to the lattice, is called thermal recombination. At higher temperatures, atoms move more widely, and the amplitude of sound waves are larger, and thus more phonons. The attraction of the electrons is generated by the exchange of phonons between electrons in individual energy states at the top of Fermi C. The Fermi C refers to electrons filling the lowest orbits or energy states within a solid. The energy of the phononic vibrations tend to be much smaller than the typical energy scale of electronic excitations, in terms of electron volts. By limiting the attraction of electronic excitations below the energy scale of the phonons, the strength of the resulting attraction differs in value from the full Coulombic repulsion between the like charges of electrons. The Coulombic interaction on this low-energy scale is reduced in strength by the high-energy processes. In calculating the interaction between the electrons which operate at or below the energy scale of phonons, it is only a reduced Coulombic repulsion that competes with the attraction generated by the electron-phonon interaction. This results in a transition to superconductivity in specific materials and certain bodies. The electronic structure advances the understanding of the quantum motion of molecular systems. If the universe is made of vibrating particles that form complex structures, the resonance of the words we use and the energy we put behind our self-expressions in every moment impacts the fabric of our cellular being and shapes our societies. But, of course, this is just a part. Thales tries to explain why things are as they are, and his thoughts are grounded in water as the basic thing of the universe. Through this, Thales marks a radical change from all previous explanations of the world, both Greek and non-Greek. Like the other pre-Socratics, Thales sees nature as a complete and self-ordering system and sees no reason to call on divine intervention or any external force from outside the natural world. Water itself may be divine for him, but it is not something that intervenes in the natural world from the outside. Thales did not think that water is tangible in itself, something that can be touched and seen, although, in his view, water is a material arche. Water is definable.